Welcome. Today we dive into one of the most powerful concepts in probability and reasoning, Bayes' theorem. This formula holds the key to rational belief. Why is Bayes' theorem so important? Because it perfectly models how we should update our beliefs, which is something human brains often struggle with. At its core, Bayes' theorem is simply the mathematical expression of belief updating, telling us exactly how to revise our prior assumptions when new evidence emerges. Humans are systematically poor at probability, prone to biases. AI, when built with Bayesian logic, handles this updating process rigorously and rationally. Psychologists have identified a major flaw in human reasoning that Bayes' theorem corrects: the failure to respect base rates. The base rate fallacy is where people ignore prior probabilities, the base rates, and overweight new vivid evidence instead. Consider a doctor who might overestimate a disease risk after a positive test, forgetting how rare the disease actually is in the general population. That rarity is the base rate. New dramatic evidence often overrides the long-term, dull statistical truth, a critical human cognitive error. So how does AI use Bayes' theorem to avoid this trap and achieve rational belief revision? The theorem mathematically links the probability of an event happening before seeing the evidence with the probability of the event after considering the evidence. Bayesian AI always starts with PA, the prior probability or base rate. It must first know the long-run probability of the hypothesis being true before examining any new data. It then rigorously updates this belief by multiplying it by the likelihood, PBA, which is the probability of seeing the new evidence given the hypothesis is true. This ensures calibration. Understanding Bayes' theorem exposes the flaws in our own decision-making processes, like confirmation bias and anchoring. Bayes' theorem demands that we consider all evidence, even evidence that contradicts our existing belief, preventing the tendency to only seek confirming data. It also counters anchoring, the failure to adjust probability estimates enough, by providing a systematic, quantitative way to ensure incremental updates based on the weight of the evidence. In essence, Bayes' theorem is not just math for machines, it's a profound prescription for human rationality. It is the cognitive antidote to irrational certainty, guaranteeing that our beliefs are always proportional to the evidence. By adopting Bayesian thinking, we can train ourselves to think more like a calibrated AI, ensuring our beliefs are grounded in reality. Remember the key principles. Always update incrementally, respect base rates, and never let a single dramatic data point override the long-run evidence.